Here we go for our second lesson to start this week. This is a good one because today we're going to take right triangles where we have two sides, two known sides, but no known angles other than the 90-degree angle, and figure out what that angle is using the same trigonometric ratios that we did before. Now I've included two examples, both from our book that you have access to at home, and also the Big Ideas Geometry book. Same information, sometimes a little bit different format. So here we go. First thing is looking at the angles of trigonometric ratios. I want you to think of it this way. Here's angle 1. We don't know what the measure of angle 1 is, but we do know that for opposite over hypotenuse, the sine of this ratio here of 4.8 over 6, that ratio would be that angle. That's what we do know. So that ratio would be that angle. So your calculator can go backwards. What we did last time, we knew the angle, we didn't know a side. So we can use the calculator to find the missing part of the ratio. But now if we know the ratio, we can go backwards to find the angle. All right. So the inverse triangle, so the sine of A equals this ratio, then the inverse sine of that ratio means it equals the angle. Okay, so on your calculator, and you're going to use there's a new term on the calculator you're going to use. It's the -1. It's the -1, but it's really called an inverse. It's not a -1 sign. It's the inverse of the cosine gives you the angle measure. So on the old calculators, or the ones you may have, you do cosine. The inverse of cosine of 0.5 would be an angle measure of 60. If the ratio of a sine, two-sided ratio was 0.45, that would be an angle of 27. If the tangent, inverse of the tangent ratio was 3.2, the angle would be 73. Now on the calculators, when you do that, they're a little bit different. On these, to find the ratio or the inverse, you need to use the yellow key and use the yellow term above the button. For the one online that I showed you, when it comes to this, again, make sure you put it in degree mode, but it's this inverse, the INV button right here. This changes. Watch what happens here. When I push this, that becomes the inverse. Now you're finding the angles if you know both sides of or if you know two sides of the right triangle. So that changes. That is finding the missing side, because the missing side of the ratio. That's if you know the angle. If you don't know the angle, we do the inverse to go back like that. Okay, so let's give that a shot. Here's another example of what they look like. This is from the Big Ideas. Same thing, the inverse tangents, finding angle measures with the calculator. So the first thing you'll do is practice with the calculator, finding the inverse of 0.75. And that will be the angle measure. If the ratio is 0.75 of a tangent, the angle is going to be 36.9. If I can move this around a little bit so you can see, and the other two are right down there behind me, but you'll be able to find those. Why can't I move my picture? Okay, next slide. Here we go. So this is how you solve. Today we are solving right triangles. So what you want to do now is this. Here is our triangle. We know this side. We know that side. We do not know these two angles. We want to find, to solve a right triangle, we need to find all of the unknown measures, meaning we want to find this length, we need to find that angle, and that angle. A couple of ways you can go about this. To find the missing length, you should be able to do that with the Pythagorean theorem. You can do that first if you choose. 5 squared times 7.5 squared. This is this method here that will give you the side AC being 9.01. That gives you all three sides. But we still don't know the angles. We do know, though, that they are supplementary or complementary, because both of these will equal 90. Supplementary, excuse me. They're going to be, okay, which one's which? Complementary, alphabetical. They're going to be supplementary angles. These two angles will equal 90 degrees. All right? They're complementary. Complementary. My brother Bill is watching this right now. He's going to call me and tell me I made a mistake. I know it now. It's complementary. The angles are complementary. I'm sure of it because I know. that complementary comes before alphabetically. C comes before S, 90 comes before 180. I'm positive it's complementary. So we know that these two angles will equal 90. Once we know all three sides, we use our inverse trigonometric ratio. So we can do we know that let's find angle A. We know the opposite side, we know the adjacent side. Opposite adjacent ratio is tangent. Opposite adjacent is tangent. So our calculator will go tangent, the inverse tangent of that ratio. We use our calculator and we'll get 34. If we find out that that's 34, then we know this one is 56, and we have solved our right triangle. We found both sides, or both angles, and the missing side. You could find this side, you could find the tangent side first. And find the tangent first, and then, like we do here, find the acute angles, and then use the Pythagorean theorem for the leg last. It doesn't matter which order you do those in. The other example for the right triangle in the big ideas, same thing. Okay, you can't see that other side over there. Hold on, I'm going to pause. There we go. This is another example of solving the right triangle. You know that these two sides, this side is 3, that side is 2. Missing side is 3. And big ideas, they go right to the Pythagorean first of all to find the missing side. Then you find either angle or finding angle B. Angle B, if we're going to find this angle, we're going to go opposite over adjacent. Use tangent B, the inverse tangent B. The ratio is 2 over 3. Plug that in your calculator. You get the tangent of 33.7. Okay, so that is that's one example there to solve the right triangle. Once you know that angle, you can find the other angle, Pythagorean theorem to get the other side, and you have solved it. So that is basically, in a nutshell, kind of quickly, how to solve a right triangle, where you're using inverse operations to find the missing angle. But two angles will be complementary, using Pythagorean theorem to find a missing side. So you have a whole lot of things now in your toolbox in order to solve right triangles. So really, that's about what we want to practice that. So what we're going to, I got to pause this again, something's wrong, hold on. So for the practice now, here's your practice of finding the right triangles, solving the right triangles. The check it out, these are on page, this is 1 through 3, about page 532, 533, the step-by-step, then those two on page 535, 14, and 15 to solve those right triangles. The solutions are posted right after this on the Canvas, so take a look at those, work them out, look at the problems, see how you get those, and then we'll follow the directions on the assignment page after that, and we'll move on and practice more of this towards the end of the week. This should be done by Wednesday, Tuesday or Wednesday at the latest, and then we'll have the practice problems both for a little bit more in-depth, more practice with 8.2 and 8.3 for the end of the week. So good job. It's kind of nice being back in the swing of things, and we'll talk to you soon.